Welcome everyone, and thanks for joining us today for this talk. Today we're going to talk about stress-free Airflow development and how do you deploy Airflow pipelines from development to production at Stripe. Let's start about us. My name is Nick. I've been in Stripe for 2.5 years, and I'm software engineer on data orchestration team who's managing the whole Airflow at Stripe. And I've been using Airflow since 2018.
Yes, and I'm Thomas. I've been at Stripe for 3.5 years as an Airflow infrastructure engineer for the entire time.
A little bit about our agenda. Today we're going to talk about specifics of Airflow at Stripe and different changes we made over the years, as well as we're going to deep dive in actually the topic of this talk is about our user testing environment, which we called user scope mode. We're going to share our learnings and as well the future development. As well, after the talk, we will stay for another 20 minutes to hold user discussion on different topics of Airflow, such as backfill, scalability, reliability. If you're interested, especially in financial space, please join us. We're going to have smaller groups here. We're going to just discuss different pain points you might face. So what is Stripe? Probably most of you already heard about Stripe before, and I hope a lot of companies that joined Airflow Summit this week, they actually use Stripe for payments. If you don't use Stripe for payments, please stay and get in touch with us. We'll figure out how to bring you to the Stripe and why Stripe should be a payment platform for you. We like to call Stripe as the payment infrastructure of the internet. Stripe employs around 7,000 people around the world, and our users in 2023 managed to process 1 trillion of USD, which equivalent to 1% of the GDP. In terms of the Airflow scale, probably everything that Stripe is doing won't be possible without Airflow and data. And Airflow, in our case, this is the core component of all our data pipelines, which is powering everything from getting transactions from our backends to the most important financial reports that we need to present to the business on the monthly basis. We have around 250 decks with 150,000 of tasks used by around 500 teams at Stripe, with processing multiple petabytes of data daily. And before we go deeper, I want to share with you some specifics that might be important to understand what we have at Stripe. Currently, we still on Airflow 1.2.10, and not simply Airflow 1.10, but specific Stripe fork with a lot of customization we made over the years. However, right now we're in the process of migrating to Airflow 2.8 in order to align everything with the upstream Airflow and in reality to stop kind of building a lot of customization in-house, but start contributing to the community and improving Airflow and the whole ecosystems with all of you and bring a lot of new features for our users internally. Airflow, our ecosystem has pretty standard set of tools. We mainly use Spark, Presto, Python, and Iceberg for all our data pipelines. As I mentioned earlier, Stripe has some specific flavors that we use, and unlike the upstream Airflow in 1.something, we don't use as much of the operators, but instead we develop over the years specific Airflow task definitions that our users should use when they specify a task. So we have the declarative way of setting outputs and inputs data sets that our users always use and need to use when they're creating a task, as well as specifying specific configuration. Later on, this is going to be everything wrapped up and used mainly by Python operator or Bash operator that we use for Airflow. And finally, meet user scope mode, aka USM, which is the main purpose of this talk. And this is the powerful concept that we use at Stripe to empower our users test their changes on the local machine as in production settings, but actually not affecting production data. What does it mean? It means that with just running the same job, if user would run in production, in USM mode, they will able to test their changes to any pipeline without affecting production data, and later on to verify how they changes are affecting production data by comparing the results, basically by checking a difference between the production data set and the one that produced by their local run. Later we're going to give into the specific details, and first we starting with how to access the data. All our users have specific entity which are transformed to every airflow task. What does it mean? That users going to access only data sets that they have access to, and this way we can keep integrity of the data and the security. Especially this is really important in our case, since we're financial organization and we need to comply with all the security requirements. As soon as user access the data, right now they need to run the task, and this is like the most important part and the interesting part of the whole USM mode. As I mentioned earlier, since our users are required to specify output and input parameters and some of the configurations, later on we are able to apply USM task patcher to all the task definitions. So in reality what we do, we change task output, we patch it, and instead of using production output, user task will start using S3 bucket, which is tied to USM testing environment specific to the user's team. The same applies to the input parameters. By default, is going to use production input on the production data on read. However, if user is running a sequence of the tasks, it will use USM environment data on the S3 from the previous task that users, from this set of tasks users is running. The same applies for the different task configuration. For instance, we're going to update Hadoop cluster in the queues in order not to use the production ones and don't affect on production workloads, but instead users task will run on specific user environment Hadoop clusters. In practice, you will see the power of the USM in the output of the task. So as you can see, this is standard output our users will see when they run in the task, and we replaced configuration for the Hadoop and as well output parameters. As you can see, the whole USM path consists from the S3 bucket, which is tied to the user and has S3 retention, about 7 days of data, as well as specific USM prefix for the user, time step of the run, and original past production output. In this way, users are able easily to go on the S3 USM location and verify the data, take a look on their runs, and analyze the outputs. So as soon as run is done, data is ready, and users want to understand how my change is going to affect production data. For this, we have data change verifier. And this is a simple CLI tool which helps our users to compare production data sets and the outputs of their testing USM runs. The CLI tool provides a set of different options which are used by our users. For instance, as you can see on this example, users are able to compare two data sets, the one that produced with their run and the one from production data by specific key. But as well, sometimes you just need to ignore some columns that might be not relevant to your change, but they might affect the comparison results, as well as different options, for instance, rounding scale, which is really useful for our users, especially in financial organization, because sometimes you don't really care about small changes like in the precision, but it can affect your summary of the result at the end. So at the end, user will see a short summary of the changes overall comparing to data sets, change count, diff count, whether the schema is matching or was it changed, and in case there are some changes in the data, users are able to take a look on those changes. For instance, an example on the right, you see that the capture amount was changed by 100, which is really important and might lead to some changes, important changes in the logic that shouldn't actually go to production. And this is the whole picture of the USM end-to-end. As you can see, user is running the task. We are checking his permission, whether they're able to access the data. We are applying different patches to their task run. And at the end, users are able to verify their changes and compare the production data with data that came from their testing run in the USM mode. So USM mode is done, testing was done, a user created PR, verified the changes, everything good to go, and it comes to how to deploy to production. Our production deployment pipeline is pretty straightforward and probably like standard one. However, we have like a small kind of additions in the sense that we use monolithic repo and we deploy and build all the PRs coming from all the users of Airflow and our data platform, which means single build file will include PRs from many users that making changes over like last couple of the hours, and the whole build time in our case takes about 45 plus minutes, and then as soon as build is over, it's going to deploy to production. In case of failure, users, however, would need to go through the whole loop one more time again. So test the changes, wait for the deploy, and as you can imagine, deploy might fail because it consists from the many other PRs from other users. And this is one of the pain points we would like to address in the future.
Yes, so that is the current state of what we have. Now, how are we trying to do better in the future? As mentioned, the thing that we have today, user scope mode, is extremely useful for our developers for their really tight inner loop of development and testing. You can iterate on the business logic of your Airflow task quickly and in a safe way. However, there are a number of downsides to the way that USM works today, a number of use cases that are not satisfied. So, one thing is it's a very manual process. It's up to the user when they're making a change to a task to know that they need to go run it and run the tool for checking if the output is what they've expected and things like that. As well, it doesn't match the behavior of the way that production Airflow works very well. The tools that we use to run the USM are an entirely custom thing that we have built internally at Stripe. So when you're running your task in USM, you're not hitting any of the upstream Airflow scheduler or worker sort of code paths. You're not using the actually CI built and deployed artifact. And so there's a lot of ways that things can be different when you're testing in USM versus when your task is actually running in production. As well, of course, there's the issue of multiple users might be working on different changes that affect the same task, and each one of them tests them separately and they all work, but when they come together, they don't work. It's especially again, because it's a very manual process, it's difficult to test long-running pipelines or large number of tasks. For example, suppose that you're an infrastructure engineer and you're making a change to the version of a Python package or something like that. That might affect hundreds or thousands of tasks. You're not going to probably go run every single one of those tasks manually in USM and verify that all of their outputs are still the same. And so it's, so for those reasons, we are working on developing a staging environment. So the idea here is staging exists as another Airflow cluster totally separate from the production cluster that we run. And it uses the same magic that we've been talking about of USM, where your task outputs are automatically redirected to some special location that's not the production location. But so the workflow would be you're a developer, you're making a change to your task, you start out making those changes locally, you go through the normal inner development loop of testing those changes within the existing USM tooling that we have. Then when you're ready to submit change, you get approval for it, it's approved, it's merged, and then before it deploys to production, it deploys to the staging environment, which again is a separate Airflow cluster from production. It uses the USM magic to, read production inputs, but write non-production outputs. And so, once your task has gone through staging and it is run and it's written as output and it is past the validations of is the output what we expected it to be? If it does in fact pass, then it can be promoted to production. And so a huge part of how we are enabling this in our system. So I think as previously mentioned, we're in the process of upgrading from a Airflow 1, highly customized Airflow 1 based system to a hopefully pretty not customized upstream compatible Airflow 2 system. And so in our Airflow 1 system, everything is one huge blob that's all together. All of the tasks and all the DAGs are all deployed together, which has a number. It's easy, it's simple, but has a number of downsides. Of course, that every single task and DAG has to be on the same git commit at the same time. It also has significant downsides in terms of the performance and cost of doing deploys. When we have, I think as mentioned earlier, we have about 150,000 tasks in our system, and once you bundle all of that up into a deploy artifact, it's about 30 gigabytes of deploy artifact. So it's a very expensive thing to build in CI. It's a very expensive thing to download during deploys. And again, one of the really big things here is that it means that every single task in our entire system has to agree on what git commit that they're on, which sort of defeats the whole point of the idea of staging, because you can't decide when your task has been tested properly in staging and advance it through to production if you have to agree with everybody in the entire system. So in our Airflow 2 system, we are working very hard to break this all apart, to get our users to refactor the way that their tasks and DAGs have been defined into a system where we can consistently load an individual DAG or a group of DAGs at a time and build deploy artifacts for individual DAGs or groups of DAGs using, at Stripe we use Bazel. So, we can define through Bazel dependencies of individual DAGs and all of their dependencies. And what this allows us to do is that we can have, within a single Airflow cluster, we can have people who are running their DAGs on different git commits. And so the way that works is that through Bazel we build container images that have within them, baked within them, the of different DAGs, and then we use those container images to run DAG processors and to deploy to worker hosts. And so through this mechanism, we can have within a single Airflow cluster different DAGs that are running on different commits. And so you can as a user, you can make a change to your DAG, you can commit it, and you can deploy it first to staging. You can do testing as long as you want within staging, and then once you've decided that you've done enough testing and that you're ready to promote the version of your DAG to production, you can do this by deploying a DAG processor for your DAG in the production cluster at the git commit that you have tested in staging. And as a result, it's no longer the case that everything that's running in production has to be on master. Every DAG can sort of be running at their own git commit that has been sufficiently tested in staging, depending on the way that the users would like to advance their DAGs through staging. All right, and that is everything